today. Not a scope meter teardown, but a Lanmeter by Fluke. This is the 683 Enterprise Lanmeter. Now, mine has some scratches on it, so bear with its beat up screen. And if I can find the power switch, there we go. It actually works, and 100 megahertz cable test compatible. So this thing glares like crazy, and it also makes a high-pitched wailing sound from the electroluminescent display. So the backlight, it's really annoying to have this thing on because it's just loud enough that you can hear it while you're sitting here. But yeah, this thing will basically test both a connection to a computer and a connection to a hub. This thing has two Ethernet ports, one to go to the hub, one to go to your NIC, and an older BNC connector. This is for coax Ethernet, which some people may not be familiar with. Oh, I just realized that there's a little flashing light. I guess that means it's trying to charge the battery. This thing does run off some big NiCads. I think my NiCads are dead though, so I've never actually seen it run on the batteries. But you can do stuff on this thing and it works just fine. You can do things like IP auto config, which supposedly gets you to an IP address so you can configure your tests and stuff, because obviously you need an IP address. Discover mode assist, sure, sounds good. Okay, searching local subnets. Well, I think it said a 20-second timeout. Anyway, while it's thinking about that, it has this cool utilization bar graph here and full keypad and lots of LEDs and status thing. Oh, okay, look, that's figuring out an IP address. Okay, that looks good. 229. No response to LAN. What is it looking for itself? Weird. Anyway, yeah, there's a serial port on the side and a little tilting stand at the back, which is pretty convenient. And this thing, it's kind of hard to tell, but this thing's absolutely freaking huge. This is a 6-inch ruler. It is larger than, oh, hang on, let me move my, it has a larger surface area than my Rigel scope. That's how big this thing is. So yeah, this thing is freaking gigantic, and it's not too heavy, but it is kind of cumbersome because you got this huge thing. You know what it reminds me of? I mean, it's bigger than the props I use, but it reminds me of the original Star Trek tricorders, like this big kind of like two-handed thing. Anyway, it does actually work. You can go into the settings and you can actually set up some tests, and it does actually work. There's actually programs on this which do they're like trial runs, which is ridiculous. Like, you know, pay to unlock this thing. See, there's quite a few settings, and this does actually show up as a if you run this web agent thing, it does actually show up as an accessible web page, and you can actually copy screenshots and stuff like that from it. So it's pretty cool. Oh yeah, 12 trial uses remain. This option can be purchased by contacting your Fluke salesperson. Oh, thank you. I wonder if they still sell it. They probably do. Traffic gen. Okay, this is the thing I was looking for. So if we go over to the traffic generator, you can run it, and then you can start flooding the, okay, so this is how many frames per second, and then you got the size of the frame. So the more frames per second you send, the more it's going to utilize the network. But if we also increase the size of the frame to, let's say, 1500, you can start flooding the network, and you can get it to the point where it's just like 100% utilization of the network. Now keep in mind that this is only 10 base T, or sorry, 100 base T, and my network's gigabit, so it's really not flooding the network itself. But as far as it's concerned, 100 megabit is as high as it can go, so it is actually flooding it completely. And you can, of course, slow it back down, and it will start to break up the graph a bit. But it's pretty cool. And if you start sending huge frames, it starts getting all these frame errors and stuff. But you know, it's kind of a neat thing. I haven't really found anything all that useful on this thing. I mean, I'm sure it does have its uses, but really all I found is like kind of ridiculous things that just go, okay, your hub is there. Well, yeah, I could have tested that with anything. I don't know if it actually, I mean, it says 100 megahertz cable test compatible. I think you need a, God, this glare is horrible. Let me see if it's any better without my, no, it's dark. Oh, well, that's no good. Need some light here. Anyway, I'll just try and keep the glare off. I think you need this like dummy thing for the other end of the cable to actually do the cable tests, because I've tried it before and it just doesn't seem to do it properly. You can do the cable scan, and I'll try the auto test. Cat 5 100 base T. Yep, okay, go for it. Lanmeter. Okay, fine. Shut down the web agent. Okay, here's some relays clicking. Yeah, see, you need the 100 megahertz remote to the far end of the cable, so it's not able to do that. So I don't have that component, so let's just open this thing up. So on the back, it's just got the usual warnings. One thing I noticed is that it says NiCad or nickel metal hydride, so obviously they have the ability to has the ability to charge both. I think mine is NiCad, but hang on, let me get my bigger screwdriver. This thing has two nice metal screws with inserts here, threaded screws. These are obviously for the user accessible portion of it, where you're supposed to be changing the battery yourself. But the rest of it has threaded screws. I believe self-tapping screws, I believe. Okay, so this just slides off and then takes the little stand with it. And there is a giant battery. Just yank this thing out. Okay, so we've got a large 1800 milliamp hour, 10.8 volt power pack NiCad, and it looks like it's made up of these like C-sized NiCad cells. I don't really want to open this thing up because it's probably all leaked and everything. It's kind of sealed. They put a bunch of ferrite on the end of this thing. And one thing I noticed is they put the key, the way they key this thing, focus, is they stick a little white piece of plastic in one of the pins. So that's how they're keeping you from connecting that backwards. And get these screws out. If I recall, I have opened this thing up before. If I recall, this actually has quite a bit of stuff in here. I think it's a mid to late 90s design. So it's pretty, there's quite a bit of hardware to get this thing to work, to give you the kind of basic GUI and stuff like that, because it's a full graphical display. And it obviously can multitask if it's when you're running that web agent thing that lets you access the internal memory and take screenshots and stuff. It does actually stay resident. So once you run the web agent, it's running in the background, and you can still access the web even though you're doing other tests on it, which is kind of, these are rather big screws. Let's see if we can get the top off. Okay, there's something attached. Okay, so we got the power supply on one half and everything else on the other. Wow, look at all the relays. Okay, so let's just disconnect this if possible. This is a actual removable connector. It may not be. Okay, I think it is. Yeah. Looks like it's just a dip style. Yep. See, it actually is like a dip package for a IC, and you can see they even use an IC socket as the receptacle. That's kind of common in older stuff. So we got a big Altera Flex. Probably some. Oh, that's an Intel chip. Oh, it's a 20 megahertz 186 chip. Lots of flash memory. Ethernet controller, Texas Instruments Ethernet controller. Bunch of DC to DC converters. Wow. Pretty densely packed. Look at all these relays to do all the testing and stuff. That's crazy. Okay, let's see if we can get these boards out. Took the power supply out. It just had a few screws. This appears to not have any screws holding it in. It's just this big ribbon cable that runs to the back of the unit. Oh, I see the display. And let me see if I can just disconnect this. Looks like a 40 pin connector. It's all the data for the keypad. Let me see if we can get this off. PCB for the keypad just had a bunch of screws on it. This thing is actually a very old keypad. It's oh no, it does say 2003. No, that's a part number probably. So it does say copyright 1992 on it. The rest of the stuff in here seems to be around 1999 or 98. So yeah, this is probably just a standard keypad they use for a lot of stuff. See the little LEDs. Wow, these actually have. They're actually quite tall, these LEDs. They're not like your typical SMD ones now. But you can see all the bare tracks that they're using for the push buttons. And all the LEDs for the network utilization bar. We've just got this thick membrane stuff. It's neat how they do the colors on this. They must just pour in the blue and the gray into the mold, and then pour in the rest of the darker gray, and then just kind of do the cap. So that's why you get this weird mixing of colors between. It's kind of neat. Anyway, very tall keys, by the way, because this thing is huge, as I mentioned. And there's a nice plexiglass screen or acrylic or something. And yeah, this case is like beat up big time. It's got these huge gouge marks in it on the screen down here. And I don't know how, like this is actually, it looks like someone went along with a knife and cut this. I don't know how they managed to do that without breaking these. So I don't know what this thing's been through, but it was not pleasant. And the case is very heavily metallized for shielding. Very thick. You can feel it, and it has the very cool coppery color. Very large graphical display. It looks like it's got a standard 16-pin connector, but yeah, you can see tons of driver chips. Ooh, made by Hitachi. And I do like the little edge-on electrolytic capacitors, and this looks like it's a resonator or something. Maybe it's a cap. Looks like it might be a cap. But, oh no, oscillator, OSC was upside down. Yeah, it's a little guy there. Yeah, big display though, and like I said, loud backlight when the thing is running. I don't even know where the high voltage supply is. The electroluminescent displays use this high voltage power supply that in general makes a high pitched sound. I've heard it in other things. I have an Apple Newton and some other things that do it. I also have one of those, the EL wire that they sell on eBay for like $1 that lights up. I have one of those, and that thing, that's just ridiculously loud. But you can see that there is space for some options. This is probably for a connector to do token ring, because they use like a DB connector on some of them for it. Token ring is an old networking type that a lot of people probably haven't heard of. It's Ethernet. The way Ethernet works is essentially everyone can talk at once. And the idea is that everyone can just talk, and in a normal network that doesn't have a switch, because switches are smarter and they keep people from talking to each other. But basically, the original Ethernet design is that anyone can start talking. So a node will just start broadcasting, and only one thing can talk at one time. So it will start talking, and if for whatever reason there's another incoming packet, it'll a collision will occur, and both of them will stop talking, and they'll basically pick a random number to wait to start talking again. And the idea is that, well, the random numbers will probably be different, so that one of them will start talking again and the other one won't, and then it won't happen. It can only really occur if they both talk exactly at the same time. I believe they're actually designed to not talk if someone's talking. So you have the system where everyone can talk, and if they overlap, then it resets and tries again. Token ring, it is actually each node gets to talk in turn, and I believe the term comes from a Native American thing where they have a stick that the person who has the stick can talk. The token can talk. They have the they have the floor in a meeting sort of thing, and so it's this token, so to speak, is passed around from all the different nodes, and each one takes a turn talking, so that way they don't overlap. And token ring had the advantage of it was faster in very, very busy environments because of the way the system worked. You wouldn't have any of this overlapping, because once older Ethernet before switches just got hammered by large networks, because you would have all these computers all trying to talk at once, and it would always be colliding. So you had to start segmenting the network and stuff. It was very complicated back in the day. Now switches actually read the packet and only send it to the port that it's destined to. They don't actually broadcast it to all the ports. Anyway, that concludes your boring computer networking history lesson for the day. Just taking a look at this power supply, and it looks fairly complicated, but from what I can tell, they're just taking the power and just sending it to the board, and it looks like they've got the local point of load DC to DC converters, because all it has is an op amp, a comparator, this benchmark chip, which is actually the NiCad / nickel metal hydride battery charger. It seems to just have the benchmark controller for the NiCad charging. It does all the battery conditioning and stuff. It also handles the nickel metal hydride type, and it looks like this separate connector goes down to the board, and then I think this is what's feeding the EL display. I think it's a separate line, because I don't think they're running the high voltage along this ribbon cable. So I don't know. This board doesn't look like it's made by Fluke. It's a slightly different color, I think. And yeah, it just looks a little different. It doesn't have their logo on it that I can see. But it's a nice board. It's very densely packed. I mean, look at this thing. The board accepts between 18 and 28 volts DC at 1.25 amps. So it's not really doing much to it, but I mean, like, it's got all these transistors and stuff. So it's I can't imagine that's all just for the battery charging and the backlight. I mean, it looks like there's a lot more stuff on it. It's probably, these are all just regulators. So I think what it's doing is it's just regulating it, and it's got these op amps and the op amp and the comparator and stuff to really get an accurate, smooth power supply. It's probably using it just for like a window comparator or something to get it really dead on, because it does accept quite a wide input range. I was wrong. There is a switch mode controller. I didn't realize this thing was 5-pin. I thought it was another regulator. I think that's a regulator. There's a MOSFET. So, yep, it is doing a switch mode conversion. Okay, onto the board. Up here, this is the Intel 8186 microcontroller, 16-bit, 186. Runs at 20 megahertz. The LAN controller, and this Altera Flex, which is an EPF 10K20. Apparently is on Mouser for $127. No. Like I said, this was a real-time clock. Just wanted to double check. It's not removable, so that must be a pain. There's a buzzer down here, and I wasn't 100% sure if this was serial, but going by the Analog Devices controller here, that's definitely serial. And these, where are they? These are actually made by Pulse. They're DC to DC converters, but they're specifically for Ethernet, and they produce a negative 9 volt unregulated output. It's kind of weird that they're so far away from each other and that they're so far away from the actual Ethernet ports. But I guess it works. And I mean, especially since they're doing testing and stuff, but they could be doing some kind of local regulation. In here is a part made by Seek, and that's another Ethernet controller. And this is a really interesting part, but we'll get to that when we get to the, I'll switch to my macro lens just because it's a pretty neat, interesting package. It's just a transformer, but it's a neat package. And yeah, I noticed that there was another spot for a token ring connector. I thought there was only the one. I know some models don't come with the BNC, and you gotta love how they are connecting it with just a standard like JST, or not JST header, but like a standard pin header through the air with just regular wire, and that's a 10 megahertz signal. Yeah, wow. The tolerances back in the day. Then again, you know, when you go to when you look at video cards, a lot of modern video cards, especially the cheaper ones, they have a low profile card and then a full profile plate. And the idea is that the full profile plate has the VGA connector, and that just connects with a ribbon to the board. And then if you want to put it in a low profile PC, you lose the VGA connector and just disconnect it and you take the whole thing off and put on the shorter plate. But the VGA connector, which is a fairly high speed analog signal, I think they're like, like for a modern one, it's like 300 megahertz or something. They're just like running it through a regular 0.1 inch pin header. So that somehow works. But yeah, that does seem a little flaky, but obviously it lets them change it out and stuff depending on the model. And yeah, 6, 7, 8, 9, 10, yeah, tons of relays on this thing. And the rest of it is all like magnetics and just Ethernet controllers, lots of bits of memory. This looks like some video memory, flash, more memory, and yeah, I think this is memory too. This is memory, probably some SRAM. And yeah, there's just like so many little bits of memory scattered around, and the rest is all like analog stuff. I think it's all like handling the testing and whatnot. Switch the digital switching to switch all the relays, and a lot of these are probably all relay drivers. And nothing on the back except well, there's a couple active devices, but for the most part it's just decoupling. There's also LEDs here. I don't know why there are LEDs. Oh, no. Okay, because this is where the LCD is. That's right. Yeah, it makes sense. Because you have the keypad here with all the buttons and the LEDs, and these are the ones that light up at the top that say hub and Nick. This is that transformer I was talking about. It's very tall, and it's a 6-pin device. I glanced at the data sheet, and it basically says it's an impedance matching transformer. So, there's nothing too special. It's just a pretty neat package. It's like, I think it's a plastic top, and it looks like it might even be a ceramic lower section. It's probably just a cap that comes off, and you can actually see the coil and stuff, because, it's not going to be anything like state of the art. It's just going to be a coil in there. I have to hand it to them. I can't find a single bodge or anything on this board. It's a revision D, so they obviously got their crap together by then. Well, I think that's pretty much it for this thing. It's a pretty impressive build. I mean, there's a ton of stuff on this board. But Yeah, you can probably do all this with one little FPGA, and you probably don't even need the relays these days. And it would, of course, handle gigabit or even 10 gigabit.